Okay, this is the third video for your Unit 2 Pre-Cal Test Review over basic trigonometry, picking up question 19. Okay, so it says determine the secant and tangent of 210 degrees. So similar to the last problem that we worked, this in the previous video, problem 18, this is just an application of your special right triangles, your 30, 60, 90, or your 45, 45, 90, and a reference angle. So 210 degrees, we start here at 0, here's 90, here's 180, so 210 would be right there. And if this is 180 to here and this is 210 to here, then this difference right here would be 30 degrees, because 210 minus 180 is 30 degrees. So your reference angle is 30 degrees here. That means this is your 90 degree angle here, 60 degrees here, and now we can label the sides. So the 30 degree side points at a side length of 1, the hypotenuse points at, or the hypotenuse is 2, the 60 degree angle faces a side that is square root of 3. Label them with the appropriate signs. That would be negative, that would be negative. So we'll use x, y, and r again. X is negative square root of 3, y is negative 1, and r is equal to 2. So secant theta, in this case secant of 210 degrees, is equal to the reciprocal of cosine. So cosine is x over r, so secant is r over x. So for us, that would be 2 over negative square root of 3. So we want to rationalize that denominator by multiplying by square root of 3 over square root of 3, and we get 2 square root of 3 over 3, and it's still negative. Next, tangent of 210 degrees, tangent 210. Tangent is equal to y over x, so for us that would be negative 1 over negative square root of 3. So those two negatives cancel each other out, so we get 1 over square root of 3. Rationalize that denominator, square root of 3 all over 3. So your two answers are negative 2 square root of 3 over 3 and positive square root of 3 over 3. So tangent 210 square root of 3 over 3, secant 210 negative 2 square root of 3 all over 3. Now we haven't done this yet in the last video or two, so let's apply our acronym. All students take calculus here, going counterclockwise just like we read positive angles, ASTC. And in quadrant 3, the T stands for tangent and its reciprocal cotangent are the only positive trig functions there. So this one is positive, check. This one is not tangent or cotangent, so it should be negative, and check it is. So that's another check you can always do. Let's move on to problem 20. Problem 20, draw a 45, 45, 90 triangle, label the lengths of the sides. Using these sides, give the sine, cosine, and tangent of 3 pi over 4 radians. Alright, so have our 45, 45, 90 triangle here. And this would be our 90 degree, this is 45 degrees, this is 45 degrees, and these special sides were 1 and square root of 2 for the 45, 45, 90. We've discussed that, we have a lesson over that. If you need more details, go back and watch that. But these are the, this would be the ratio of the sides for a 45, 45, 90. So now we're going to use that to answer this question. So we have 3 pi over 4 radians. Again, at this point in your trigonometry career, you're more familiar with degrees, so it's always okay to convert that into radians. Later, we will get familiar with radians and where 3/4 or 3 pi over 4 would be. But for now, you're mainly used to working with degrees, so that's what we're going to do. So we multiply by 180 over pi. This cancels, and that is going to give us 3 times 180, all divided by 4, and that is 135 degrees. So if we make a sketch of this particular problem situation, we have 135 degrees would be in quadrant 2, so here's 0, here's 90, and here is 135. So the reference angle here, if it's 180 to here and 135 to here, that means this little angle right here we could find by doing 180 minus 135, and that would be, put the degree symbol there, 45 degrees. So we have our 45, 45, 90 triangle, 45, 45, 90, and we can label the sides. So the hypotenuse here, or the R value, is square root of 2. The X value is -1. The Y value +1. So here is everything that we need to answer this question. So our X value there is -1. Our Y value there is +1. Our R value there is square root of 2. Now for the trig functions. So sine of theta. Now you should know it's Y over R. So for us that's 1 over square root of 2, which is square root of 2 over 2. After you rationalize the denominator. Cosine theta, you should know by now, is X over R. So for us, that's just going to be, start being able to shortcut this. Look, in a 45, 45, 90 triangle, the sine theta, the cosine theta are going to be the same because your adjacent and opposite sides are the same no matter which angle you use in here, whether you use this one or this one, regardless of which 45-degree angle you use. So you should see that it's going to be negative square root of 2 over 2, but let's just go through it anyway. -1 over square root of 2, so that becomes negative square root of 2 over 2. So same, just with different signs based on the quadrant that you're in, but the absolute values are the same. And last one is tan theta. I keep using theta here. I should have used the radians. I'll go back and fix that in a minute. So tan theta is always equal to y over x. So for us, that would be 1 over -1, so -1. I'm going to go in here. I should have done this. I'm always, or often, guilty of this. I always put theta. And we have the angle here, so we should use it. 3 pi over 4 radians. So cosine of 3 pi over 4 there. Sine of 3 pi over 4 here. And tangent of 3 pi over 4 here. So we have sine of 3 pi over 4 is square root of 2 over 2, positive. Cosine 3 pi over 4 is negative square root of 2 over 2. Tangent of 3 pi over 4 is -1. Let's check using our acronym. So we'll use orange here, ASTC. So we're here in the second quadrant where only sine and its reciprocal cosecant should be positive. And that's what we have. That one's positive. Everyone else should be negative there. Cosine is negative, tan negative. So our signs are correct. So that's just another check that you can always do. All right, one more to go. 21, question 21, and we'll be done with this video and done with the review. All right, problem 21, last one for this review. Use a calculator to evaluate the following expression. The angles are in radians. We know that because there's no degree symbol listed here, and the other clue is it's in terms of pi, and most of the time radians are in terms of pi. So we have this 147.2 times the quantity sine of 5 pi over 3, 5 pi over 3, subtract cosecant of 14.3 pi. Well, cosecant, we don't have a cosecant button, so we have to use its reciprocal, 1 over sine of that value, 14.3 pi. And we're going to type it in our calculator just like we see it there, and we'll get the answer. We need to make sure we're in radian mode. We'll do that in a minute. So parentheses sine of, I'm going to use the fraction button here, alpha y. Let's try that again. Alpha y equals enter. That's the fraction button, so that would be 5 pi in the numerator there and 3 in the denominator. That's very helpful, so you don't have so many sets of parentheses going on here. And then I'm going to use another fraction bar here. Alpha y equals enter gives me that, and 1 is in the numerator, and sine of 14.3 second pi. Didn't take the second button there. Let's try that again. Second pi. Actually, I hit the wrong button, so it did exactly what I asked it to do. Close that parentheses, close this parentheses, and hit enter. And we get negative 309.428. And let's double check the mode. We're in radian mode like we're supposed to be, and this is our answer. So that's it for this video. That's it for the review.